Hello everyone and welcome back. Alright, so in this video we're going to plot some of our data on both required reserves, excess reserves, and total reserves in our class. So I'm going to just start, I've just opened up RStudio. If you're using RStudio Cloud, of course you probably have opened up the project that we've been working on in the past. Go on ahead and start by bringing up a brand new script file. So I'm going to go to File, New File, and our script file. Of course, there's a key command, and if you eventually you'll learn that key command. But for now, I'm just going to navigate to it using the general user interface. And of course, the first thing we're going to want to type out is we're going to need some libraries here. So I'll type out the library command. And the first one that we're going to need that we've been using so far in the past is going to be the tidyverse. If you're, like I said, if you're using the same project within RStudio Cloud, this package is probably already not only installed but also currently loaded. So this library command is going to be a little superfluous, but that's okay. If not, though, then of course you'll want to execute that. So I'll go ahead and execute this command. I already have tidyverse installed, so yeah, we should be good to go. Now, the next package that we're going to download, you may not have currently in your setup within RStudio Cloud, or if you're using the actual native RStudio application, you may need to install this package. Again, I'm going to follow with just my own personal preferences here. I never put an install package command up top here in my script file, so I'm going to click down here on the console and I'll do install.packages. Oops, if I can type. So notice here, this command, install.packages, that's going to be the command to download something from the CRAN. And inside of quotes here, I'll put the title ggpub_r. And so this is going to download a collection of additional commands that kind of help for putting together, they're kind of specialized commands, and there's going to be one in particular that we're going to need a little bit later here. But the idea of this package is to have a whole bunch of individual components that you can help to take plots from ggplot2 and to kind of make them publication quality. So after that, we'll then put back up here in our script file our library command again, and we want to make sure that we load that package that we just downloaded. So we'll execute that command as well. Of course, it doesn't give us any message like the tidyverse library command, but we want to make sure that we actually do execute that library command. So this is the first kind of hurdle, so to speak, of making sure that we understand the logic of you can download a package. And if unless you actually use that or call that with the library function, you're still not able to actually use it. So now we've downloaded it, we've used it, we're ready, we're good to go. All right, so and I'm actually going to create some additional kind of headers here. I'm real big on kind of making my script files look pretty, so to speak. So I'll use the hashtag or the pound sign to comment out, and I'm just going to type in load packages, and then I'm going to do a space, and I'm going to do 4 kind of dashes. And what this does is this kind of turns this commented line into a header. So if you go down here into this really tiny little place here, below at the very bottom of the script file, and you'll see you'll see basically exactly what I typed out, load packages. And this is kind of create a little section, so to speak, within your script file. This is very helpful if you're creating long script files, because then you can actually jump back and forth between different things. So we'll do that, and then I'm going to create another one down here, and I'm going to type in load data, and then type out 4 hashtags again, or dashes again, because so now you'll see a second little header showing up there. So it allows you just to skip back into a previous section of your code as long as you're working neat. And then I want to paste into this the original load URL command that we have that loads all of the data for our Econ 312 class. So please go back and see the previous videos, or actually if you're in the 312 class, you're going to find this this specific command and URL within our Slack channel. So I want to make sure that I load that, or excuse me, execute that command, and then we see all the various data frames that contain the data for this class. All right, so now we'll create another section here, and we're going to title that Clean Up Data. So we actually need to do a couple of things with this data. So the first thing I'm going to do is I'm going to just go over here to my global environment, and I'm going to select the reserves data. And I'm just going to click on it once, and of course this will produce the view command down here below. But we have this reserves data frame. On the first column, we have all of these dates at a monthly frequency starting in 2000. And then you'll see two columns of data, TR and ER. TR is going to be total reserves. ER is going to be excess reserves. And notice that these things are in different units. So you see TR is really, really small, and you'll see ER is really, really big. And that's because TR is going to be in billions of dollars, and ER is going to be in millions of dollars. So we need to do something about that. We need to put these in the same unit. Now, it kind of doesn't matter what we do. So we can either take the TR that's in billions, and we can convert that into millions by multiplying it by 1,000, or we can take the ER, which is in millions, and we can convert that into billions by dividing by 1,000. It doesn't really matter which one you do. I'm going to keep this all in millions of dollars, so we'll start with that. The very first thing I'm going to do is then I'm going to kind of save over that column of data. So I'm going to type out reserves in all caps, since the actual object that we have here is in all caps. I'll use that $sign to kind of delimit between, so that I can specifically call out one specific element of that reserve data frame. And then I'll call it reserves, $sign, TR again. And then we're going to multiply that by 1,000. And then we'll execute that line. So now if we go back over here to the reserves column, notice that everything kind of is in a similar scale, which makes sense here because excess reserves are going to be some component of total reserves. So we should always expect excess reserves to be lower than total reserves at every single point in time. If that doesn't work, then we've got a problem here within fractional reserve banking. And holy crap, we need to sound the alarms. All right, so now because we have total reserves and we have excess reserves, we do not have required reserves. So we're going to create required reserves. So I'm going to create another column here, again within the reserves data frame. And here I'm going to create something that doesn't exist. So I'm going to say now I'm going to create another element within the reserves data frame called RR. And if you create something that already exists, it just saves over it. If you create something that doesn't exist, it's going to append it to the original data frame. So we're going to create this RR column here, and this is going to be the reserves in total minus the reserves in excess. So we'll go back to the reserves data frame, and we'll see, great, sure enough, we've created another column here, and the sum of excess reserves and required reserves, it will then equal our total reserves. So now we have all of our various elements that we're after here that we're going to be plotting. And what we're actually going to do is we're going to generate a plot that has already been produced within our slides. So you've seen this plot before from my class, but it's not a line plot per se. It's something slightly different. So I wanted to be sure to kind of show you how to generate that plot, and then we're going to play around with it just a little bit by truncating some of the data. So we're going to create a ggplot object here, and we want to be sure to give it the reserves data frame. That's going to be the data that we're actually actively wanting to play with. We're going to define some of the aesthetics of this. We're going to say on the X column we want our date, just like within a time series plot. And then on the y-axis, we're going to put total reserves. Now, in this case, we could have put something different. We would have just started with maybe required reserves. But once we do that, we're going to build this plot in layers. And so if we actually put required reserves instead of total reserves first, we probably would save right over top of it. And so then you wouldn't be able to see required reserves, and that would be a problem here. So here we're just going to specify the first object kind of in the background, so to speak, is going to be our total reserves. And then we're going, instead of doing geom line, we're going to do geom ribbon. And what this will do is it'll effectively do a line plot, but then it's going to shade all of the area below the line plot. We'll again use that AES or aesthetics function inside of the geom ribbon command. And here we need to specify the minimum. So the y min is going to be 0 because we don't want to be dealing with negative. So it's just going to be in the upper quadrant. And then y max, we want to set that equal to the upper bound of our data, tr. I'm going to arrow out of that aesthetics command, and then I'm going to put fill. Now, if you use just color here, then you're going to get the color of the top of the ribbon, which is going to be the line itself. And then everything below that's going to be gray. So here we want to use the fill command. So we want to basically say, I want everything below that. And I want to show you guys that you can, we can do a couple of different ways to specify color here. I'm going to express color here as a hexadecimal code, which hexadecimal, hex meaning 6. So it's basically all possible colors expressed in a digit of 6 alphanumeric codes. And so, or 6-digit code. So here we're going to type out the number 3 4 times, B2. And that'll give us a nice blue shape, or blue shade rather. Again, we'll arrow out, do a plus sign. And then we're going to do another geom ribbon right over top of that. And this is where we're going to specify our required reserves. So again, we want y min equal to, excuse me, I cannot type. Butterfingers. We'll specify our y min equal to 0, and then our y max is going to be equal to our required reserves. Arrow out again, and then we'll specify fill. And in this case, I want the fill equal to, there's all kinds of different color names that are built into R. So here I'll just pick a nice red, which in this case is going to be Firebrick 2. Of course, is there a Firebrick 1? I believe so. And I don't know how many Firebricks there are. I haven't really gone to look, but I just know there's a Firebrick 2, and I like Firebrick 2, so we're going to use it. So, fantastic. Now, I'm just going to execute this. I'm not going to fix any of the labels yet, but we'll just go ahead and take this and run with it. So, let's run this command. And sure enough, right over here within the plots pane, and let me zoom out so I'll make this bigger. Yeah, we can see exactly the kind of general shape that we have within the slides for this class. So we can see that we have total reserves in blue. We have the required reserves within the banking system that are red. And for the longest time, and I could have taken this data prior to 2000. If we go back into the 1980s, 1970s, I've seen some long-form data for this. It's exactly the same. It just goes ever increasing down. It basically looks like a flat line compared to the big mountains of excess reserve financial capital floating around in the banking system today. But effectively, we get the exact same picture here. The amount of total reserves is just a hair more than what's actually required. And so banks don't really hold a lot of excess reserves, that extra insurance policy against deposit outflows, prior to what happened in terms of the economic policy response to the Great Recession. Fantastic. So let's clean up our labels here. I'm going to add a plus sign, so kind of indicate for this ggplot command to keep going. We'll add our labels to this. Great. On the x-axis, we are going to, again, just put nothing here because notice it prints down here not only the date tick marks, but then the name date because that's the column name. I don't want that. I just think that's kind of redundant and silly. So we'll basically specify for the x-axis, I want nothing. And then for the y-axis, I want to print this in millions of dollars. Now, keep in mind, this is nominal. This is not real. I have not deflated this in any way to account for inflation. So we'll just put nominals in it, or millions of dollars. And if we want, we can even do a little parenthetical. We can just do nominal if that makes us feel somewhat better. I don't know. Maybe it does. Maybe it doesn't. But we'll go ahead and do that nonetheless. And then over here for our title, we'll put total and required reserves. Fantastic. And so then we can execute that again, now with some nice pretty labels all along the y-axis and the top. All right, fantastic. We have a nice little pretty graph here. Are we done? No, I don't think we are. So I'm going to create another little section here, a little commented header here, and I'm going to say intro to filter. And so what we're going to do here is I'm actually going to say, I'm going to create a different way of expressing this data. It's going to be the same way, but we've already talked about the interest on reserve policy that the Fed has started to implement, where it's paying an interest rate on these reserves that banks are not only required to hold, but in some cases also hold in excess. And so I already kind of made the connection that we get this large rise of this mountain of blue financial capital as a function of that policy of setting an interest rate. But we didn't really kind of talk about the connection in terms of a time component here. So we're actually going to build two different plots. One that starts there's going to be a replication of this data that starts right around here where I'm moving my cursor. And then we're actually going to plot the interest on reserve interest rate below that, so that we can kind of get a time component and kind of see exactly kind of the interplay between these two events. So in order to do that, we need to filter some of this data. And so now I'm going to introduce you to a component of the dplyr package that we've already loaded within tidyverse. And the dplyr package is basically a whole package of collected functions that allow you to kind of manipulate and query data. And so that's effectively what we're going to do here. So I'm going to introduce you to a slightly different way of coding some commands here. The first thing we're going to do is we're going to type out reserves, and then we're going to use something called the pipe operator. If you're using a Mac, this will be Command-Shift-M. If you're using a PC, it's Control-Shift-M, and it'll generate three kind of characters of a percent sign, a greater than sign, and followed by another percent sign. And you can actually type this out too, and it'll do this exact same thing. But this is a way of stringing together different commands. So effectively say, okay, I want to start with something, I want to then do something else, and you can kind of tell the computer to keep on going. Very similar to like the plus sign logic within ggplot2, but it's a bit more flexible. So after I type in this this pipe operator, I'm going to hit enter. It's automatically going to kind of indent a little bit, and we're going to use the function filter. Notice here it'll kind of autofill here with the dplyr function. We'll open up parentheses like any other function, and here I'm going to type in, I want the date, and I want this to be greater than or equal to, and here's where I have to be exceptionally careful. I've got a font on my RStudio that supports glyphs. And so as soon as I hit the equal sign after my greater than, it automatically is going to create a mathematical greater than or equal sign. And then people are going to wonder, how do I get that? But this is really two different characters here. In fact, I can even move my cursor over, and notice now my cursor is in between the two. So kind of be careful with that. This is slightly problematic, and my apologies. It'll do the same thing if I put two equal signs, it'll kind of connect them together, or if I do a less than or equal sign, it'll generate that as well. But here I want a greater than or equal sign. If you don't have a font that supports glyphs, then this will just show up as greater than and an equal sign just right beside one another, and that's perfectly fine. So I want the date that is greater than or equal to, and then I'm going to type inside of quotes 2008 01, or pardon me, 10/01. So we're going to start this in October of 2000, or on October of 2008. I almost said October 2001. I'm like, no, that's not right. All right, so so this is going to basically just truncate the data. It's going to start it at the date that's greater than or equal to October 2008. And then we're going to do this pipe operator again. We're going to effectively tell it, okay, now that we've got this subset of the reserve data, I want to keep on going. And here I'm going to be a little lazy. I'm going to grab the plot that we just created. I'm going to copy it all, and I'm going to paste. So let me make this a little bigger so you can see the full command. So here we have effectively strung together a whole bunch of commands, but more specifically, we strung together 3 distinct things that we're after. We started with the full reserve data frame. We filtered that to just give me the dates that are at October of 2008 and beyond. And then we're going to plot them just in the exact same way that we've done. So I'm just going to throw my cursor anywhere here. I'm going to execute that. Ooh, what did I do wrong? Mapping should be created with an AES. It was created with an AES. Beg your pardon. Why are you saying you don't like that? Oh, excuse me. I know what we did wrong. I did something fundamentally stupid here. I need to take out this portion of ggplot. See, this is the idea of a good coder is a lazy coder, but the lazy coder also needs to make sure they do their due diligence. So what I've done here is I've made a simple mistake here. I've created a conflict here. So we have the reserves data frame. I filtered it, and so if I take this portion out, it'll immediately just start working with the data that I have. Instead, I've now confused it by giving it the full reserves data frame all over again, and that was silly of me. So if we take that portion out of the ggplot2 or the ggplot command and just immediately start with how things should look, then we can execute that line, and we have our data exactly the way it should. So you kind of have to get a sense of what the pipe operator is doing. We start with something bigger, we filtered it down into something smaller, and then I immediately, from this command here, from this little collection of symbols, I've piped that result directly into ggplot so that that's the starting point. I don't have to specify the data anymore because I'm taking that directly to the plot function, so to speak. And so when I pasted it in there, I just got a little ahead of myself, and I should have deleted that when I didn't. All right, see, that's great. See, this is why I don't really want to edit my videos, so that you, as we get stuck, we see error codes happening in real time, and then we're able to fix them just the same way that we would do in a normal classroom lecture environment where I can't edit that out either. All right, so here we have our plot. Like I said, this starts towards the end of 2008, so we've eliminated all that small string of really small values at the beginning here, and we're really just starting to see at the beginning of policy. And this date's going to be important to us because we want to start looking at the interest on reserve policy. Before we do that, though, I want to save this. So I want to pipe this into an object, so to speak. So I'm going to take this arrow, and instead of doing I'll scroll up here. Instead of doing a left arrow up here, we can also pipe this using a right arrow. So I'm going to pipe this into a named object, and I'll just call this reserve _ plot. So now I've saved this whole plot, including the filtering of the data, as its own separate object, reserve plot. If you go over here to the global environment, you'll see we have that, although it kind of truncates because of the size of the font, and you'll see list of 9, and it's got 9 different elements. All right, so great. I'm now going to go over to the interest on excess reserves object here, and we'll see that this data starts on the 9th of October 2008. So we're not going to get perfect lineup here. This is daily data, and of course it's not necessarily complete because it's going to be subject to banking holidays and things like that. But it's effectively going to be banking data or daily data. So this is not going to line up perfectly when we plot this over top of our total reserve and required reserves, but it's going to be effectively close enough. So we're going to plot this as a time series object. Let's do that. I think that'd be a lot of fun. So we've done this before. We'll start with our ggplot command. We want our interest on excess reserves. Now, of course, keep in mind from our class, we talked about this. The actual policy allows the Fed to separate this and to create a separate interest rate for excess reserves from the interest rate they pay on required reserves. Why they're paying an interest rate on required reserves, I still could not actively tell you. I've asked a couple people at the Fed. They still don't have a good answer for that. They just are. But the two policies right now are set in tandem, so they're the same interest rate for both of them. I imagine there's probably also some logistical problems that they would have to fully untangle if they actually wanted to separate those and make those two separate interest rates. So the fact that I'm just plotting the interest on excess reserves, it's also the same as the interest on required reserves. So that's not necessarily an issue here. If they actually start to do something with that, well, then it might become one. So we'll use the Aes function here. We'll specify again, we want date along the horizontal axis because that's just what we do in a lot of macro stuff. On the y-axis, we want interest on excess reserves. Careful, this is lowercase. So if we go to the IOER object here, notice that the actual column of data has a lowercase name, not an uppercase. So please keep that in mind. In this portion of the command, we were trying to feed this a data frame that has a capital. In this portion of the command for the aesthetics, we want the y variable itself to be the lowercase column name of the actual data. So we do need to be case specific there. We'll arrow out, hit a plus sign. We want a geom line. Fantastic. And I'm going to specify a color in this case that is equal to exactly what we had before. That way it kind of matches the same blue line that we have with the geom ribbon. You don't necessarily have to do that. You could leave it black if you wanted to and just not specify a color at all. I guess it's okay. You know what? I mean, whatever you want. We can be flexible here. I think it's okay. For our x variable, again, because I'm picky, I'm going to take off the column name for the x-axis label. For the y-axis label here, I want to make sure that we specify this as a %. And then we also need to give it a title. And this title, we will title this interest rate. Oh my goodness. Patrick, clumsy fingers. Interest rate on excess reserves. Fantastic. And then we're just going to pipe this directly into a separate plot function. So I'm going to execute this, and then the plot's actually not even going to show up, so it's not even going to be there. If you want to see that here, we can go down to the console. We can type in the name of what we just called it, and lo and behold, there it is without too much fanfare or trouble. Although I'm wondering where my title went to. Got my y-axis, but my title's not there, and I'm kind of miffed about that right now. Oh, well, hello, because I didn't spell title right. Again, clumsy fingers, butterfingers. And there's my title. Okay, yeah, oops, my bad. All right, so great. So the very next thing we're going to do is we're going to stack these things. So we're going to use the function ggarrange from that ggpubr package that we downloaded earlier. So this is the main reason why we have that. So this is a small little wrapper function that allows you to take multiple ggplot objects that you've saved and then to put them and stack them together either in a grid format or in a column format. And you have all kinds of flexibility to be able to do this. It's actually really remarkably cool. So you can create all kinds of crazy arrays and layouts for tables. It's fascinating. And I'll try to use this a little bit more as we move on throughout class. So we're first going to type in our reserve plot. We're going to then feed it our interest on reserve plot. And then I'm going to give this, since we're just doing a very simple example here, I'm going to set the number of columns equal to 1. So that way it stacks it in a vertical column. And then we're going to execute that command. And the more objects and the more data you input into this ggarrange function, the longer it's going to take. I've seen some cases where I'll execute this command and then it takes like a couple of minutes because there's so much going on that it's trying to parse out exactly how to build the actual the plot that we're after. So I'll hit the zoom button again on that so we can make this nice and big, and then we can kind of talk about it a little bit. So this is something that I didn't do within the actual slides for the class, but probably I should have. So I figured I'd at least rectify that here. In a normal class environment, I would just do this in real time, but at least we'll capture it here in the video. This doesn't quite line up perfectly. Recall that our interest on reserve data is daily data. It also starts a bit after the beginning of the month, and so notice here that the 2010 tick mark doesn't quite line up with the 2010 tick mark for either of the two panes. Same thing for 2015, same thing for 2020, but you get loosely the right idea here. All of a sudden, we start paying interest on reserves. Prior to this, the value was effectively zero because there was no policy here. So now the Fed is paying an interest rate on the amount of excess reserves that banks are holding. So they start to kind of hoard a little bit of cash. This is, of course, both simultaneously expansionary policy and contractionary policy at the same time. It's expansionary because it allows banks to build up their balance sheets in order to be able to withstand deposit outflows. But it is contractionary at the same time because when banks are holding on and hoarding that cash, they're not lending it. Thus, it is contractionary policy as well. So we see this kind of this spike in this interest rate policy. Of course, this interest rate policy is bound by whatever is happening with the discount rate. If banks can just go to the discount window and borrow money and then hold it in excess reserves and get a higher interest rate, then we create an arbitrage opportunity. And banks just indefinitely borrow to infinity from the Fed, and that just doesn't work. So instead, this is kind of bound by what's happening with the discount rate. When the discount rate hits the first era, the long-term era of the zero lower bound, or the effective zero lower bound, as it should be said, because it's not actually zero, it's at 0.25, then we still see interest on reserves, or at least reserve balances rather, exploding. Now that kind of makes sense because we have some compound interest happening here. But at the same time though, you would think that as the opportunity cost of holding on to these excess reserves drops, that banks would be more likely to lend. But it actually turns out not to be the case. This is a function of the business cycle ruling the policy. And so we're going to find here that as the interest on excess reserves, as it drops, as that rate drops, we actually tend to see increases in reserve balances because of what's happening in the underlying economy. Banks don't want to lend, and so they're willing to just begrudgingly take this return. And that becomes the alternative. It becomes truly the default risk-free rate of return, so to speak, rather than the return or the yield on a T-bill. But we don't really start to see any kind of substantive drawdown of what's happening to reserve balances until we actually see the interest rate go up. And so that kind of indicates then what's happening is we start to see the economy kind of rounding a corner. All of a sudden, economic activity is booming. Banks are willing to now take the risk. And so they substitute away from that. The opportunity cost of not lending out goes up too much then. And so this rate ends up just not even being enough compared to the return that they're leaving on the table by not lending. And so we actually, as this interest rate ticks up, because the discount rate is moving up, we actually start to see kind of a period of general decline and drawdown of total reserve balances. Then, of course, 2020 comes along and it just whacks us upside the head with a 2x4. And so all of a sudden here, the economy is in peril. The Fed fires most of its shots that it has right in March. Of course, it would say that it has many more shots left, but one can argue. And then all of a sudden, the interest rate on excess reserves plummets down again to the zero lower bound, or the effective zero lower bound, I should say, and then the amount of reserve balances shoots up again. Again, this is more governed by what's happening with the underlying economy. So this whole graph of total reserves, the total reserve balances, as well as the interest rate on excess reserves, it kind of moves opposite of what you might initially think it to. The top pane really is driven by what's happening with the general economy, and not so much necessarily by banks acting strictly within the guise of, I want to get that risk-free return. The risk-free return is an important part of it, true, because clearly we wouldn't see the kind of movements that we have seen in the larger historical context. But this is a bit more of a nuanced picture once you see the ribbon of total and required reserves over top of the actual time series plot of the interest rate on excess reserves. Thank you so much for watching. If you're just a random YouTuber that's come across this video, feel free to leave a comment below if you have any questions. If you're one of my students, probably the faster way is to message me on our Slack channel, and I'll get an answer to you if you have one, or especially if you have an error or something coming across, and by all means, send me your code. Thank you so much for watching. Take care.